Hello, class. Today we're looking at Chapter 9, Lesson 3, Sample Spaces. So when you go to a salad bar, you can choose from different vegetables, fruits, and dressings. You may want to know all possible combinations of ingredients you can use. The collection of all possible outcomes in an experiment is the sample space. You can use the sample space to find the probability of an event. So let's write down sample space, the collection of all possible outcomes in an experiment. Okay, so now let's look at an example of a sample space. So this says make a table to find the sample space for rolling 2 number cubes colored red and blue. Write the outcomes as ordered pairs. So what we are doing is these are the 2. So the cubes have 1 through 6 on them. So, and then there also could be a red one and a blue one. So as we go through, we're writing all of the pairs. So you could have a 1 red one, 1 blue one, and they both roll 1. Or it could be 1 and 2, 1 and 3, 1 and 4, 1 and 5, 1 and 6. And then the same thing can be done but with the blue ones. So over on this column, it's the blue 1, the blue 2, the blue 3, the blue 4, the blue 5, the blue 6. So these are all of the outcomes that you could come up with if you did the 2. And see, there's just a pattern. These are all the red 2s, all the red 3s, all the red 4s, 5s, 6s. And then the other direction, they are adding in 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So this covers all of the possible options. And as we look through here, there are 36 options, 36 different chances, possible outcomes that we could get. So this says find the probability of rolling at least 1 3. So if we look here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right? There are no other 3s. So the probability is 11 out of, what's the total? 36. 11 out of 36 possible outcomes could the probability of rolling at least 1 3. So let's look at the example that they would like you to do on your own. Give the sample space for tossing 2 coins. Find the probability of getting 2 heads. So just think about that for a minute. Press pause. Come back to me when you're done. Okay, so this is the chart I came up with, it, right? Heads, tails, heads, tails. You roll them together. We could have 2 heads. We could have head, tails. We could have tails, heads, or we could have tails, tails. And it asks for the probability of getting 2 heads. So really there's just 1. So 1 out of 4 chances. So the probability of getting 2 heads is 1/4. Now let's look at using a diagram tree. So suppose you are going to travel on a river. You have 2 choices of boats, a kayak or a rowboat. You can go upstream on 3 smaller streams to get to the north, northwest, or northeast. What is the sample space for your journey? Make a tree diagram for the possible outcomes. So if we have a kayak, right, we could either go north, and so then our outcome's going to be kayak north. We could go northwest, so then our outcome's going to be kayak northwest, or we can go northeast, and then it's kayak northeast. These are the three outcomes for the kayak. Then we have the rowboat, and the rowboat can go north, so then we have rowboat north. The rowboat could go northwest, rowboat northwest, or it could go northeast, rowboat northeast. So these right here, 1, 2, 3, 4, 5, 6, there are 6 possible outcomes. So suppose you select a trip at random. What is the probability of selecting a kayak going directly north? Well, there's only one option, that is a kayak going north. So therefore, it's going to be 1 out of the 6 options. So the probability is 1/6. Okay. I don't know why I did this one so far low. I think I thought we were going to have some work to do with that. But let me just point out a couple things with both of some of these up here. So just to be aware, right, there's 2 coins, and we're looking at heads and tails. 2, 2. So 2 times 2 equals 4. 4 possible outcomes. Up here, there were 6, a 6-sided dice, right? And the other side, the other dice has 6 sides. 6 times 6 equals 36. Okay, so it's important to realize and being able to diagram these, but I want you to also know how to solve them without drawing pages of examples. Okay, so suppose a canoe is added as another choice of boat in example 2. So right now we have 2 boats, 3 directions. If we have another one, so we can just say boat 3. It still is going to be that they either go north, northwest, or northeast, right? So this is going to be another option. I guess I should have done it the right. This is going to be another option. And this is going to be another option. So we're going to add 3 options. So before there were 6. Oh, and look at it says to draw the sample space. So that's right here. So there were 6 options before. We're adding 3 to it. 9. So now there are 9 possible outcomes. So now, finding the probability of selecting a canoe at random for the trip. So think about that for a second. Come back to me when you're done. Okay, so I didn't label this real well. This was actually a canoe here. So 3, right? We said that this was 3. So there were 3 possibilities, 3 times possible that we could select a canoe out of 9. Well, we could reduce that down because each side could be divided by 3. So therefore, 1/3. We have 1/3 chance, probability of selecting a canoe. Okay. So now let's look at the counting principle. Suppose there are m ways of making one choice and n ways of making a second choice. Then there are m times n. So this is kind of skipping back to where I was trying to give you guys clues of how that works, right? You can just do m times n ways to make the first choice followed by the second choice. So if you choose a shirt in 5 sizes and 7 colors, then you can choose among 5 times 7 or 35 shirts. So let's look here. We have currently 1, 2, 3, 4, 5 different types of breads. And then we have not crossing them out. 1, 2, 3, 4, 5, 6 types of deli meats. So, right, to do all these, right, we could draw a chart. 1, 2, 3, 4, 5, 6. Rye could have 6 different types of meats on it. But after knowing what we know up top, we can just do 5 times 6 equals 30. Therefore, there are 30 different possibilities you can have based on these options. So now a manager adds chicken to the meat choice. Now how many options are available? So think about that for a second. See if you can figure it out. Come back to me when you're done. So there's still 5 types of breads. Now there's 7 types of meat. 5 times 7 is 35. Therefore, there are 35 options now available. Your homework for tonight is page 321 and through 323, numbers 7 through 21 odd. Happy homeworking!